Hi guys, in this video we're going to talk about density and how you calculate it. And to do this we're going to be using some Cornell paper, so let me get over to that. So here we go with our Cornell paper. Remember that you want to fill out your name, class period, and date, and our objective is density calculations. And we have two essential questions. What is density is the first one. And the second one is, how is it calculated? So the first thing we need to do is talk about what density is. So let's go ahead and do that now. So density is a property of matter. It is just something that every object has, and it is the ratio of mass to volume. Now for density we use the letter D. D is for density. In math class, when you hear the word ratio, you should think a fraction. That's what a ratio is. And in science class, mass is an M and V is a volume. So the equation to find density looks exactly like this. Density is mass divided by volume. So when we're talking about density and density calculations, that is the equation that we're going to use. But to kind of understand a little bit more about what density means about an object, is we're going to use this definition: how close the particles are. So if I draw a couple of pictures here in some boxes, I'm going to use some particles. Let's see, we'll use some tiny ones. So if I draw some tiny particles here, wow, those are really small. And you can see that they're so small you can hardly see them, but I drew 6 there. And if I draw them a little bit farther apart, now I have something that is more dense. I'm sorry, less dense. Farther apart is less dense. So if I compare these here, we'll call this one A and this one B. At this point, A is more dense than B. So I've got my greater than on the A. A is more dense than B. Now if I draw another picture with some bigger particles, let's see what these look like. And I've tried to draw them in about the same spot as I did in B so that I can make a point here. When I look at these, because those particles are bigger, that means they have more mass, and so box C is also having a greater density than B. To compare A and C, we might need to know a little bit more about the particles and just exactly how close they are, but I'd have to guess that C is more than A just based on the size of those particles I drew. So we can talk about density from the terms, or from a particle diagram, which I think is a later objective, so we'll get to that. Okay, so density is how close particles are. Let's flip over to the back of our Cornell paper. Here it is, and let's do a couple of calculation examples and talk about how we're going to do the calculation. Okay, so here's our first example. If you need to take a minute and pause so you can write that example down, go right ahead and do that now. So I'm going to read it, and it says that the density of a piece of wood that has a mass, what is the density of a piece of wood that has a mass of 25.0 grams and a volume of 29.4 centimeters cubed? Okay, so I'm going to write on this a little bit. I'm going to underline what I need to know here. I need to know that the mass is 25 grams and the volume is 29.4 centimeters cubed, and it's asking me what is the density. So I'm going to start by writing down the formula, which is D equals M over V. This is a map that tells me where to put numbers. So D is what I'm looking for. I'm going to draw a little arrow here so I can have some room later. D is what I'm looking for, so I'm going to keep that. M stands for mass, and it tells me the mass is 25 grams. I'm going to go ahead and keep the G. V is for volume, and that's 29.4 centimeters cubed. And so now this is telling me to do some math. When you have a fraction like that, you're going to be dividing. So I'm going to take the numbers only, just the numbers. I'm going to kind of section these guys off here that will be used later. Don't be tempted to use that 3. So when I plug this into my calculator, 25 divided by 29.4, I get 0.85 and some other numbers, and I'm just going to stop there. I'm going to round to 2. The next number is a 0, which makes me want to leave it at a 5. And then I need a unit, and that unit is what I just circled there. Grams per centimeter cubed. I didn't cube anything, okay? This is the answer for my density. So let's get a second example up here, and we'll do that one too. This one was a little bit easier. The next one will be a little harder. So here's example 2. This one, I'm going to read it and mark on it at the same time. Find the mass of a 50 milliliter, that should say piece of bronze, if the density of bronze is this right here. Okay, so what we're looking for is find the mass, and then we have 2 numbers here. We have density, and we have this milliliters, and it doesn't tell you what it is, but you know that milliliters measures volume. So we're going to start like we did last time, and we're going to jot down that equation. D equals m over v. And this is still my map, so I'm going to use it to tell me where to put the numbers. And density, it says, is 9.87 grams per milliliter. And over here, I got a lot of extra dots there. I wonder if I can erase those. Okay, I don't know about that other one. Grams per milliliter. Okay, and then mass goes on top, but I don't know mass, so I keep the m. And volume goes on bottom, and so that's where the 50 milliliters goes. Okay, so when it comes to doing this kind of math, it might be easier if you leave the units out. And then we'll talk about how to think about the units. So I have 9.87 equals m over 50. Okay, this is exactly like finding x in math class. It's exactly the same. So in order to get m by itself, we have to get rid of the stuff on the bottom. So I'm going to multiply both sides by 50. Currently, I'm dividing m by 50. I have to do the opposite. So that's going to make my 50s go away. And so I'll have m left over here. And then I need to plug into my calculator 50 times 9.87. And I get 493.5. All right, so then I have to think about my unit. So I'm going to look right here, and I'm going to look right here. Now I have milliliters and milliliters, so those are going to cancel out, and I'll be left with grams. So 493.5 grams is my answer. Okay, so we'll do a few more examples, but we might need some more space here. I don't know if I have enough. Let me see here. Now I probably need some more space on a different page. So you can use a different paper. If you think you've seen enough examples and you want to get going, that's fine. You can always come back and watch more examples later. Okay, so here we are with example 3. This one's going to be a lot like the last two, but maybe a little different. This one says a lead cylinder has a mass of 540 grams and a density of 2.7 grams per milliliter. Calculate the volume of the lead cylinder. So this one is got the same set of information, but we're going to be doing a tiny bit different piece of math. These are the hard ones. Calculate the volume. Those are the hard ones. All right, so we're going to start with the equation. Density equals mass over volume. It's my map that tells me where to put the numbers. It says to write 2.70 grams per milliliter there, and then it tells me to put 540 grams on top and a V on bottom for volume. And then because I think it's a little easier to do the math without units, I'll look at the units later. I'm going to write 2.7 equals 540 over V. Okay, most common mistake people make here is dividing by the 540. Because, well, you got to get V by itself, but when you do that, you're going to leave V on the bottom of a fraction, and you can't do that. So the first thing that you have to do here is multiply by the junk on the bottom. That's okay, junk on the bottom. We did that in the last example too. We multiplied by the number on the bottom. This time it's V. But either way, if what you're looking for is in a fraction, you got to multiply by whatever the junk is on the bottom. So I'm going to be multiplying both sides by V. So that's going to make my V go away from over here, and I'm going to have 540. Over here, I'm going to have 2.7 times V. Now I need to get V by itself, and so I'm going to divide both sides by the 2.7. So that's going to make these guys cancel out, and I'm going to end up with V by itself, which is what I wanted. And then I need to plug into my calculator, 540 divided by 2.7. Oh, how awesome. It comes out to 200 even. Now, a little note about this. In the problems on the quiz, you will have to enter in your answer to be graded with a set number of decimal places. Now, this came out to an even 200, and my unit is going to be, let's see, the grams will cancel out, and so my unit will end up being milliliters. So this is going to be 200 milliliters, but to enter it, let's say the question wanted me to round it to 2 decimal places. That means I have to have a decimal followed by 2 numbers. So what am I going to enter in? To enter, I would write 200.00 ml. So that is what I would type into the quiz, okay? That is a useful thing to note because it will count it wrong if you don't do it that way. So if you're worried about that, you can always ask your teacher to take a look at it. Okay, so let's do one more example. All right, this example is a 2-part sort of example, but it's not terribly difficult. It says a cup of gold colored metal beads was measured to have a mass of 425 grams. By water displacement, the volume of the beads was calculated to be 48.0 centimeters cubed. Given the following densities, identify the metal. Okay, so it doesn't really say it here, but your goal is to find the density. So that's what we're going to start with. So here's our equation. D equals M over V. Now I like it when I have to use this one because I don't really have to change anything. D equals tells me the mass was 425 grams and that it took up 48.0 centimeters cubed. So when I plug that into my calculator, 425 divided by 48.0, I get 8.85 grams per milliliter. Now that doesn't actually answer the question because it says to identify the metal. Okay, so this is the density. Which one does that match? Well, if you picked copper, you would be right because that copper one is the closest value to what I have. It's not exactly 8.86, but it is the closest, so this must be copper. All right. So if you need any more examples or you have any questions about how to do this, make sure you ask your teacher. Thanks for watching.